Next, we're going to look at a parallel circuit practice, and what we're going to have going on here is we're going to have 3 resistors, and these are going to be in parallel to a 24-volt power source. So what we're going to do is we're going to start by drawing the circuit, and we're going to put 3 resistors in here, like this. And the first one is 1,000 ohms. The next one is 4,700 ohms. And the next one is 5,600 ohms. Okay, so we know that in a parallel circuit, the resistance is determined by taking 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3, like that. So we're going to take 1 over RT, and that's going to be equal to 1 over 1,000 plus 1 over 4,700 plus 1 over 5,600. Okay, so if I take my calculator and I'm going to go 1 divided by 1,000, that's 100,000, plus 1 divided by 4,700 plus 1 divided by 5,600. And I'm going to get some number that's very small, like 0.001. What I need to do is I need to flip it. I need to go 1 over it. So I need to divide 1 by that number, or x to the minus 1, and I end up with 718.73. 718.7329 ohms. Okay, so that's what I end up with my total resistance. So if I redraw this circuit right here, and I go 24 VDC, and I simplify it with a simple circuit here of 718.7329 ohms. Okay, so I'm back to using my power wheel and my Ohm's law to get my current. I is equal to V over R. Okay, so my voltage is 24 volts, and my current is 718.7329 ohms. Okay, so I divide those two out. 24 divided by 718.7329, and hit equal there. I get 0.033. I'm going to round that up to, I got 0.334 amps. All right, 0.334 amps. So that is the amperage that is running through this right here. And so what happens is this voltage source is going to produce a current of 0.0334 amps. But when it gets to this first node right here, it divides. Some of it's going to go this way, and some of it's going to go this way. And then with the remaining, it's going to get divided again between these two, and then they'll come back and join up, and they'll join up, and they'll all come back, and the total will come back to be 0.0034. So we need to determine how much current is flowing through each one of these. Okay, so what we know on these is that in parallel, voltage stays the same. So we have 24 volts potential between this top line and the bottom line here, 24 volts between here. So we know that this is dropping 24 volts DC, and this is dropping 24 volts, and this is dropping 24 volts. Okay, so now we can use my formula, I is equal to V over R again, to get each one of these. So I would say the first one is going to be 1,000 ohms over 24 VDC. I equals V over R. So I got that backwards, excuse me. 24 VDC over 1,000 ohms. The second one, 24 VDC over 4,700 ohms. And the last one, 24 VDC over 5,600 ohms. Okay, and so if I divide those out, 24 divided by 1,000, I'm going to end up with 0.024 amps. The next one is 24 divided by 4700. I'm going to end up with 0.0051 amps. And the last one, 24 divided by 5600. I end up with 0.0043 amps. I rounded up. Okay, so those were my amps on each one. This first one was 0.024 amps. The next one was 0.0051 amps. And this was 0.0043 amps. Okay, and so just to check, remember that all these amperages, the total amperage gets divided up, and then it must return, and it must equal to this right here. So if I take the sum of my amps here, it has to equal back to there. So let's try it. I total is equal to 0.024 amps plus 0.0051 amps plus 0.0043 amps. Let's see what all that equals, all right? So I'm going to add that up. 0.024 plus 0.0051 plus 0.0043 equals 0.0334. This equals 0.0334 amps, which is what we determined was the total amperage for this circuit. Okay, so that was just our parallel circuit practice.